This video will cover performing operations on date and time data in LubriDate. By the end of this video, you should understand how R performs logical tests on date and time data, and how you can perform mathematical operations such as adding and subtracting time on date and time data. The R code that I show in this video is available on Elms, and you may want to take a minute to download it and open it if you'd like to follow along on your own. The first types of operations that we'll consider on date and time data are logical tests. You should remember that when R performs a logical test, data types need to be the exact same before the test is performed. If they aren't, R is going to try and make a conversion. In general, R is going to try and convert date and time data into date times if the data types don't match. If there's missing information, for example, if you're trying to convert a date into a date time, R is going to assume all of the missing components are 0. So for example, if you wanted to convert January 1st, 2001 into a date time, it would convert to January 1st, 2001 at 0 hours, 0 minutes, and 0 seconds. Once R has performed that conversion, logical tests work exactly as you expect. Greater than represents a time that is after, less than represents a time that is before, and equal represents a time that's the same. Also remember that with date time values, R compares moments. So it's going to take time zones into account and return true if the moment is the same, not the number that somebody would have read off their clock in that time zone. So just as some examples of this, 5 p.m. Central Daylight Time equal to 6 p.m. Eastern Daylight Time will return true, because if those are on the same day, they represent the same moment, even though the clocks don't read the same numbers. Conversely, testing 5 p.m. Central Daylight Time equal to 5 p.m. Eastern Daylight Time will return a false. Even though these clocks read the same numbers, these don't represent the same moment in time because these two time zones use different UTC offsets. The same logic also applies with greater than, less than, greater than, equal to, or less than and equal to. Let's perform logical tests on date times in R. Remember that you need to load the LubriDate library separately from the tidyverse. I'll do that now. I'm going to define a few date times and a date, just so I don't have to do so much typing. The variable dt1 will be equal to 8 p.m. on October 5th, 2018 in the America/New York time zone. dt.2 will be 3 p.m. on October 5th, 2018, again in the America/New York time zone. And then lastly, date.1 will just be a date value, which will be October 5th, 2018. If you perform a logical test comparing a date to a date time, R is going to coerce that date into a date time value, setting all the components that it doesn't know to 0. So testing whether date.1 is equal to dt.1 will return a false, because R assumes that date.1 is at midnight, 0 minutes, and 0 seconds on October 5th, 2018, whereas dt1 is 8 p.m. on that day. Logical tests on dates and date times work exactly as you would expect them to. Here I show you 3 logical tests. In the first one, I test whether or not dt1 is equal to dt2. They're 2 separate moments in time, and as you see, I get a false. Next, I check whether dt1 is greater than dt2. dt1 is farther in the future than dt2, therefore it is greater, and I get a true. Likewise, I test if dt1 is less than dt2. dt1 occurs after dt2, so that result is false. Remember that when R performs logical tests on date times, it compares moments in time, not the times that people read on their clocks. I'm going to define 2 date times here. dt.6.ny is 6 p.m. on October 5th, 2018. I set the time zone to America, New York. dt.6.chi is that same clock time, 6 p.m. on October 5th, 2018, but I've set the time zone to America, Chicago. If I test if these 2 times are equal, R returns false. Why is this? Again, even though these 2 times read the same on a clock, they don't occur at the same moment because these are in 2 different time zones. I'm going to define a new date time value, dt.5.chi. This is 5 p.m. on that same date, October 5th, 2018, in the America/Chicago time zone. I test if that is equal to dt.6.ny, and R returns a true. That's because 5 p.m. in Chicago is the same as 6 p.m. in New York, since they're in different time zones. Those two clock times occur at the exact same moment, therefore R returns true. Another common task in your data science workflow might be performing mathematical operations on dates and times. You might want to compute the interval between two dates and times, or you might want to add or subtract some set amount of time to an existing date or time value. So how should R let you do these things? For example, if I wanted to know how much time elapsed between two date-time values I have in my data, what do you think I would type in? Hopefully it's intuitive that you can compute the span of time between two date or time values by subtracting one from the other. Likewise, if you want to add some amount of time to a date or time value, you can use the plus operator to add time. Finally, you can remove amounts of time from a date or time value by using the minus sign operator. Let's perform some mathematical operations on some date times. I'll define two date times. dt.1 is August 27th, 2018 at 10 a.m. in the America/New York time zone. dt.2 is December 18th, 2018 at 8 a.m. again in the America/New York time zone. If I'd like to compute the amount of time that elapsed between these two date times, I can just take dt1 and subtract it from dt2. I store that in a variable called span.1. And here if we look at it, it tells me it's a time difference of 112.9583 days. What exactly did we get from R here? We can determine the type of an object using the typeOf function. If I take a look at span1 using typeOf, R tells me it's a double, so it's stored as a number. Spans are numbers, but they're stored in a very special way. I can extract just the number using the as.double function here on span1, and it just gives me the number 112.9583. As you saw in that example, spans are the way that R stores differences in date times. These are numbers with a special unit attached to them. R is going to decide what the best unit to use is. For very short spans, it might use things like seconds or minutes. For long spans, it might use things like days or years. If you use the as.double function to coerce a span into just a number, R is going to use the unit that it chose. Sometimes you might wish to use a different unit of time. If that's the case, you can change units using the units equal to and then putting the name of a time unit in quotation marks as part of that as.double function. Let's look a little more closely at spans. I'm going to define two date times again. dt.1 is 10 a.m. on October 27th, 2018 in the America/New York time zone. dt.2 is 10:48 a.m. on that same date in that same time zone. Just like before, I can compute the difference by subtracting one date time from the other. Notice now when I print it out, it tells me a time difference of 48 minutes. Remember the last time I computed a span, it told me the time difference in days. Here the time difference is much smaller, so R has decided to use minutes instead. If I coerce that value to a double, R gives me the number of minutes, 48. Remember last time, when it decided the days were the appropriate length of time to use, it gave me the number of days instead. You might like to be explicit about the units that you use. You can do that just by adding the units equal to and putting the unit that you would like inside quotation marks. Here in this example, I say that I'd like the unit to be days, and it tells me that's 0.0333 days. R keeps track of the units when it uses spans. If you remember, span.1 we defined before was several days. If I coerce that to a double using the unit seconds, I get about 9 million seconds. Span2 was just 48 minutes, so if I coerce that to seconds, I get 2,880. I can construct a new span, I'll call it span.3, just by adding span.1 to span.2. You notice if I take a look at how long it is, R correctly kept track of units and added that 2,880 to the 9,759,600. You can perform other mathematical operations on date and times. Perhaps you might like to add some amount of time to an existing date or time. You can just use the plus sign and numbers. So for example, if I had a date time dt.1, I could use plus and 10, and R would add 10 to it. 10 what, you might think? When R doesn't know what unit to use, it's going to guess. With date times, R will always guess seconds, so it would interpret that expression as take date time 1 and add 10 seconds. With the date data type, R is always going to guess days, so in that case it would add 10 days. It's probably much better to be explicit about the units that you would like to use. LubrDate provides several handy functions for being explicit about the amount of time that you would like to add. For example, if you'd like to add 10 seconds, you would use 10 as the argument to the seconds function. There's also a minutes, hours, days, weeks, months, and years function that do the exact same thing for different units of time. We can try adding some values to date and time values. In my first example, I take a date time August 27th, 2018 at 10 a.m. in the America-New York time zone. I add 5 to it without specifying the unit, and you can see R takes that date time and adds 5 seconds. If I do the same thing for a date, taking August 27th, 2018, and I add 5 to it, R interprets that 5 as a number of days, and I get September 1st, 2018. It's always better to be explicit about the units that you're using. I could take that first date time and add 5 seconds to it using the seconds function. I could add 5 minutes using the minutes function, 5 hours, 5 days, 5 months, or 5 years. I can do the exact same thing with date values. Remember, the date that I defined before was August 27th, 2018. I can add 3 days. I get August 30th, 2018. I can add 3 months, getting November 27th, 2018. Or I can add 3 years, giving me August 27th, 2021. If I try and add a time component, for example, hours, minutes, or seconds, to an existing date, R will first coerce that date into a date time, assuming the missing components, the hours, minutes, and seconds, are 0, then adding the amount of time specified. Here I've added 5 minutes to that date, and that gives me 5 minutes after midnight. As you can see, LubrDate supports a variety of methods for performing mathematical and logical operations on date and time data that all, I think, follow our intuitive understanding of time.